Welcome back to another video, y'all. I've been working on this robot the past few nights, playing around with it. I've actually got all the systems basically ready to roll here, but yeah, you can see they're not attached to the robot while I'm testing stuff out and playing around with it. I've actually built this kind of robot before, but this is my first time using this particular motor controller right now. So I have it all hooked up. This is not going to be like a real in-depth, real theoretical type video or anything. I'm just going to tell y'all exactly how I'm using this motor controller. And yeah, I'll show you a little code. We'll look at a few hookups and whatnot. And yeah, it might help you out if you're trying to use something like this for the first time. So first of all, let's talk about all the things that are on the desk here. This is a robot chassis that I showed in my last video that I built. I built 3 of them total. This is one of them. It does have 2 motors on it, 2 little DC motors. I think they're made to run at like 6 volts or so. Pretty cheap, but they work pretty well. I have those connected to, you can see the motor controller here. I have the motor controller connected to the Arduino. I also have a potentiometer going on over here, and we have a battery pack with 4 AA batteries in it. So it's making about 6 volts or so. So why do we need a motor controller? We need a motor controller because the Arduino microcontroller, the pins cannot handle the kind of current that a motor will use. So you have to use something in between you could talk to tell it. So basically the Arduino is going to tell this thing how much power to send to the motors from these batteries. So these batteries go here, and then the Arduino kind of directs the action, and then this motor controller sends power from these batteries to these motors. So that's kind of the whole idea here. So let's look at everything that's hooked up though, and then we'll look at the code. Like I said, we're not going real in depth. We're going over just basic function of operation. So when you look at the motor controller, this is an L298 chip here, and it has a huge heat sink on it. These little guys cost maybe $4 or $5 or so. Maybe you can get them cheaper if you're willing to wait a while from China. So these 2 terminals here and here both go out to the motors. A red and a black wire are connected to each one of these terminals. So you can control each motor independently. Now you also see we have wires on this terminal connector here. We have the positive or the hot going to the 12 volt line. It's kind of confusing because it actually says 12 volts, I believe. Yeah, it says plus 12. You can actually put, I think 5 to 12 volts in right there. And you can actually even use more than that. I think up to 24 volts. Then you have to take this little guy off, and then your motors, of course, have to be able to use 24 volts. But yeah, I have 6 volts going in here on that 12 volt line. And then of course the ground is going there also. Now something else important to note on this connector is you see there's a jumper that's hooked up there. I have the ground connected between the Arduino and the motor driver circuit. So they're both on the same potential. So you may not want to forget that too. I just have it plugged into ground and then going into that same ground connection there. Then these other lines that are hooked up to the motor controller, there's 6 of them, okay? There's called an N1, you can see there, hopefully. Let me move the wires. There, you can see through there, I think. There's enables for both of the motors, and then there's an N1 and N2, N3, N4. So the basic operation is so N1 and N2 are both for motor, we'll call it A, for instance, okay? So to make motor A spin, you have to set either N1 high and N2 low, or the other way around. You can go N1 low and N2 high. That's just going to change the direction of spin. One will be clockwise, the other will be counterclockwise. So you just N1 high, and you'll see it in the code here in a minute too. And then also for motor A, you'll have an enable for A. And if you want to use that, you could send a pulse width modulation. We'll look at that in the code in a minute too. You could send pulse from 0 to 254. I think that's right. No, wrong. It's 0 to 255. That's what it is. Using analogWrite to your motors. And that will actually control the speed of the motors. That controls how much power is being sent to the motor. So enable controls speed, N1 and N2 control whether the motor is actually on and what direction it's going to turn in. So we have 3 of these connectors, 2 Arduino pins for each one of the motors. So 6 total connections there. Let's see, on the Arduino, all we really have going on, also we have is this potentiometer. And we'll look at the code here in a minute. We're going to use the potentiometer to control the speed of the motors after we turn them on in the little demo. And yeah, if this was actually going to be mounted on the robot, I would probably have a separate power supply also for the Arduino. Probably use a 9-volt battery going in through the barrel jack here. But yeah, that's all the physical connections that have been made. So hopefully that makes sense. Okay, let's look at this code real quick. And please understand, I am not a programmer by trade or anything. So just the fact that I can stumble through and get this working is enough for me. It ain't pretty sometimes. But let's look at the code real quick. These are all global variables that are being declared at the top of the sketch. And you can see I'm just declaring the N1, N2, N3, N4. I'm telling, I'm setting like which pins these are going to be. So these are going to be pin 0, 1, 2, and 3 on the Arduino. And then we have those enable pins I was talking about for each one of the motors. I'm making those 10 and 11. Now these have to be capable of PWM. So make sure you choose 2 pins that can actually do PWM so we can do our analogWrite. Only the PWM pins can do analogWrite. And if you look at your Arduino, if you see the numbers next to the pins, the ones that have the little tilde symbol next to them, and it even says it, digital PWM. Any of the pin numbers that have the little tilde next to them are capable of PWM. So as you can see on here, 10 and 11 are capable, so that's why I chose to use those for the enable pins. Also, we have sorry for that camera work. Also here we have a pot pin, and I'm just declaring that A5, which is an analog pin, over on the other side. I think it's over here. Yeah, over here. We're using that analog pin there because it's going to read the value from this potentiometer later on. So that needs to be an analog in. So we can use that analog to digital converter that is there. Okay, so we're setting that to A5 over there. This is just a variable I'm going to use later. Drive and convert it, and this is kind of messy, but I'll show you why I did that later. So that's all of our pins defined there at the beginning, and then we're setting all of them up as outputs except for pot pin. We're going to set pot pin up as an input because we're going to be reading from it. Now here's the loop, and yeah, drive. That's that variable I made. That's where we're gonna actually read the value from pot pin. So it's gonna give us a value from 0 to 1023 coming off that pot pin, okay? And now I have this other variable for converted, and we're using this map command. If you're not familiar with it, look it up. Look up the map command on arduino.cc. It's really a very useful command. But we're saying, okay, take this drive variable that's going to range from 0 to 1023, And instead of going from 0 to 1023, we want you to make that range 110 to 255. And the reason we're going 110 to 255, on the upper end, 255 is 100%, is the highest setting for PWM on the Arduino. That's 100% duty cycle. And then the reason I'm using 110 as the bottom edge, so like if the potentiometer is turned all the way down, 0 will actually be 110. The reason I made it that is because I found that anything below 110 for the PWM and the motor stalled out. So I did not want that to happen. I found that even at like 105, one of the motors would just stop, and that's not good for the motor just to sit there on stall current for a long time. So I made the minimum 110, so they'll always spin. Also, I said if drive is less than 50, the converted equals 0, because I just want to make sure it just turns totally off. So hopefully that makes sense. That's kind of messy coding. And then here you can see we're doing digital writes. We're setting N1 and N2 to high and low, and N3 and N4 to low and high. And the motors are going to be spinning different directions based on that. But that kind of works out because the motors are mounted opposite each other. So if they're both spinning a different direction, then the wheels are going to be moving the same direction, if that makes any sense. So we're just setting them to both spin in the same direction. And then we are using this converted mapped value from up here, and we are going to analog write that value to each one of the motors. So they should conceivably spin at about the same speed. And that's the end of it. So yeah, that sketch that it took me 10 minutes to talk about, or whatever, 5 minutes, whatever it is, only uses 4% of program storage space. So anyways, let's go ahead and do the demo. Okay, so I'm just gonna plug this into the computer just to power the Arduino. We've already uploaded the code yesterday, and so I know it works unless something has gotten disconnected or something like that. And then we have our potentiometer here ready to go, ready to roll. And I didn't put a switch on it, which I kind of should have. So I just leave one battery out until I'm ready to do it, and then put the battery in. And okay, yeah, if it's all the way to the left, which it is now, that's gonna be basically a 0 that it's reading. If it reads less than 50, then that means it's gonna be off. So that's why the motors aren't turning at all now. Now, if I go just a little bit, the motors will kick on. And if you notice, they're spinning, they're not super slow. They're spinning at, that's a 110 duty cycle right now that they're spinning at. And as I turn the potentiometer, that's full speed now. Pretty cool, right? We turn it back down. And I made this to where I could not reach stall current. It would just shut it off. There, you see it just goes from that speed to off. But I thought it was a pretty cool little demo. And of course, if we go in to the code and we change, say, if you set N1 and N2 both to high or both to low, the motor won't turn at all. So let's change it. We're gonna set low, and then we'll set this one to high. And now the motors, after I upload the code, you'll see that one motor will spin one direction, the other motor will spin the other direction. Oh, problem uploading. Okay, wait. See, I might have to set the ports. Arduino Uno, here we go, that should do it. I think that's probably the problem. Yeah, that was it. And now you can see this one is turning like this, and this one is turning like that. So if everything was connected and the robot was actually down, it would be spinning in a circle right now. So whenever I actually get this thing, everything mounted on the robot, and I go to program the code, I'm probably gonna have several routines. One will be, okay, both motors spinning and get the same rate going forward. Well, that would be like the forward routine. I would have one with both motors going backwards, the same speed. That would be the back routine. I might have a slight turn left routine where you set one motor less than the other, and then that'll make it kind of drift that way. Or you may want like a spin, like where you turn, like do a 180-degree turn. You can do that too. Send one forward and one backward at the same rate. It'll just spin basically on its axis because it's almost round. So yeah, that's what we're gonna be doing next, is getting all that set up. And yeah, that should be the next video. I hope y'all found this useful. This is the kind of video I think I would have liked to have watched before using this little guy, this L298N. Thanks for watching. Take care, guys. Have fun.